Welcome to the Intro to the Solar System. Today we're going to be looking at the planets, the moons, and other objects in our solar system, how our solar system formed, and how solar systems outside of ours around other stars have formed and how we've detected them. To begin, let's just look at the planets. We have the 8 planets that you already know: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And we're just going to look at more details about these 8 planets. To start with, look at their average distance from the sun, right? I mean, this is what gives them their order, right? And we've got this big jump. Mars is at 1.5 AU, out to Jupiter at 5.2, then up to 9 and 19 and 30. So as we go out in the solar system, the jump is bigger and bigger. You look at their size. All right, relative to the Earth, make the Earth 1. So Mercury, Venus, Mars, all smaller than the Earth, although Venus is pretty comparable in size. But then Jupiter, 11 times. Saturn, 9 times. Uranus, 4. Neptune, essentially 4. The other really big difference comes in the mass. So if you look at the mass, we take the Earth and say the Earth is 1. Then Mercury is 0.05, just a 20th of our mass. Venus 0.8. Mars is a 10th of our mass. But then Jupiter, over 300 times our mass. Saturn, over 95 times our mass. Uranus, 14, 15 times our mass. And Neptune, 17 times our mass. So when you start looking at some of the statistics on the planets, you get a better feel for how they differ in size and mass, and also in terms of the other thing that's interesting here is their average density, right? So rocky, not as dense, right? Mercury and Mars, not as dense. But then you get out into the gas giants, and they're much less dense because, well, they're made of gas mostly. If we're going to try and look at relative sizes, now these distances are nowhere close to correct, but if you look at relative sizes, you can see Jupiter is by far the largest. Saturn in some ways looks larger, but that's because of its rings, but it's a good bit smaller than Jupiter, than Uranus and Neptune. In terms of planet types, the inner planets, Mercury, Venus, Earth, and Mars, are all rocky planets. Sometimes we call them Earth-like because Earth is a rocky planet, and we don't mean they're fun to live on like Earth. We just mean that they're also rocky. And then you've got the outer planets that are all gas giants. This isn't an accident. This isn't just happenstance. In the section on how the solar system formed, we'll get to why this is. All the planets have orbits that are close to the plane of the ecliptic. There's not much tilt in the orbits at all. Neptune has a little tilt, not much. Most of them nearly in the plane of the ecliptic, not much movement at all. Pluto is a good bit out of the plane. Pluto is, I think, at like 30 degrees or something like that, but most of these are pretty close. They're all their orbits are also very close to round. Eccentricities close to 0. So they're very close to being a circle. All the planets orbit in the same direction. So it's not a matter of, oh, Earth goes this way and then Uranus goes that way. Nope. We all go around the sun in the same direction. All right? It doesn't matter which planet you have. It's all in the same direction. Now, all of these kind of help give us some clues about how the planets formed and how the solar system formed. Again, we'll get to that later. When we look at the terrestrial or rocky planets, Earth is the most massive, right? 5.9 times 10 to the 24th kilograms. All of these have solid surfaces. They all have rock and metal. They're all pretty comparable in just terms of what they're made of for the most part. Then we get out to the Jovians, or the gas giants. The gas giants 4 to 11 times the size of the Earth, much lighter densities. But again, Jupiter here, 1.89 or 1.9 times 10 to the 27 kilos. All right, call that 2 times 10 to the 27. Go back to Earth, 6 times 10 to the 24. It's 10 to the 24 versus 10 to the 27. That's a factor of 1,000. So it's a lot heavier, a lot more mass, pardon me, a lot more mass than the Earth. Their composition, all right, tends to be different. Are the inner planets, terrestrial planets, rocky, a lot of iron, oxygen, silicon, um, things like that. Density high. The outer planets, mostly hydrogen and helium. All right, inner planets less than 2 AU out. Outer planets more than 5 AU out. Very different composition between the two. And this graph may be a little hard to read, but let's go through some of the key features. All right, the interior of Mercury is an iron core, rocky core. The interior of Venus is a nice rocky core. The interior of the Earth is an iron nickel core with iron nickel plasma around it and a rocky exterior. Again here, a rocky exterior around the iron nickel core, rocky exterior around the iron nickel core. Same here with Mars, small iron nickel core, rocky exterior. Now, if you look at these, Mercury has a magnetic field, Venus does not. The Earth has a magnetic field due to its plasma, the iron nickel plasma that's in the core, and then Mars does not. All right, if you look at the composition of the atmospheres, well, there's none on Mercury. It's mostly carbon dioxide on Venus. Earth, nitrogen and oxygen. Mars, carbon dioxide and nitrogen. A little bit of nitrogen on Venus as well. Then you get to the Jovian's moons. There is still on inside of these, there's this core at the middle, and then there's liquid hydrogen and helium. And again, for Saturn, a core at the middle, then liquid hydrogen and helium. And this, the outer planets, that core is a rocky core, not an iron nickel core like ours. And you get to then Uranus, it's got the rocky core, and then around there is liquid water and ammonia, and then hydrogen and helium. And the same for Neptune, rocky core, liquid hydrogen and ammonia, and then external surfaces, helium and hydrogen. When you look at their atmospheres, mostly hydrogen, some helium, mostly hydrogen, helium, methane, hydrogen, helium, and methane. The Jupiter's axis, Jupiter has a magnetic field, its axis is nearly perpendicular to its orbit. Saturn's axis is tilted several degrees off, just like ours is tilted a little bit off. Saturn's is more off, closer to 45 degrees. Uranus axis is straight at in its plane, right? So Uranus's axis is in its plane of rotation, making it very different. And Uranus's magnetic field axis is way off from its rotational axis. If you look at Neptune, it's tilted about like the Sun. It has a tilted axis, and its magnetic field axis is off quite a bit from the rotational axis. All right, that's just a bit about the about the planets, and in the next segment we'll talk about moons and other objects in the solar system.